Okay, so we just created an additive pattern and we graphed it. And we found that when we graphed our pattern or graphed our rule where we're adding together something to x to get y, we get this nice, beautiful line right here. Well, it's a little, I think it's beautiful. So let's look at this pattern right here. Y equals 2x. Okay, so what's the difference between this pattern up here where we had y equals x plus 2 and y equals 2x? Well, just like when we are solving expressions and the number is right next to the parentheses without an operation in between the two. Remember when it was like this and we had maybe 8 plus 3 in here. And then we solved 8 plus 3 and we got 11. And then there was something we were supposed to do with the 2 and the 11. What was it? Do you remember? I hope you remember that it was multiply. When a number is right next to the parentheses without an operation, it means multiplication. Well, it's the same thing here. When a number is right next to the variable without an operation in between the two, it's just another form to show, another way of showing multiplication. Remember how I said that mathematicians love to use the letter x for a variable, and so that's why we have stopped using x to mean multiplication, and that's why. So here, the x doesn't mean multiplication. The very idea that the 2 and the x are together without an operation in between them, that means multiplication. Because my my rule could also be like b is equal to 2a, and that also means multiplication. So I could say, oh, I want a to be 0, and I'm going to multiply 0 and 2 together to figure out what b is. Okay? Our variables don't always have to be x and y. They just usually are. And so that's what we are using here. Okay, so when we are multiplying in order to figure out what y is, then our pattern is called, it's a very big word, so I'm going to type it for you. It is multiplicative, a multiplicative pattern. That means we are going to multiply whatever we decide x is, we're going to multiply it by our number here, in this case 2, in order to get y. So let's figure out some x values and then see what y is going to be. Once again, we get to choose what x is going to be. And so I always love to start with 0. Okay, so I'm going to plug in 0 for x and figure out what y is. So if I do that, I'd be saying 2 times 0 is equal to, well, what's 2 times 0? 0, right? It isn't 2, that's 2 times 1. So every time x is 0, then y is 0. Let's come up with another number. Let's say 1. So I would say 2 times 1 is equal to, well, what is 2 times 1? It is 2. So every time x is 1, then y is 2. And let's keep going. Let's say x is 2. So I'm going to plug in, instead of putting x, I'm going to put 2. So 2 times 2, and that would mean 4. So when x is 2, y is 4. So let's write our 3 values or ordered pairs as ordered pairs, putting them in the parentheses, and then we're going to draw a line and see what our multiplicative pattern line looks like. Okay, so let's do 0, 0, 1, comma 2. Whoops, sorry, this looks really messy. And 2, comma 4. Now, once again, I'm just taking my values from my table and making them ordered pairs so I know how to graph them or put them on the graph. Okay, let's start with 0, 0. Well, where is 0, 0? That's a special place on the graph, isn't it? What is the special place where they intersect? What is that called? It's where it all begins, is the origin. So our first plot, our first part of our line is actually going to be at the origin. Okay, what else? Let's do 1, 2. So remember, we always start at the origin. I'm going to go over 1 for my x value and up 2 for my y value. So I'm going to put my dot right here. And then let's do 2, 4. Starting at the origin, I'm going to go along my x-axis 2, so go to the right 2, and then up my y-axis 4. Okay, so actually share a spot with our additive pattern. Let's do one more just to see where the line is going. So in order to do that, I need to plug in another number for x and see what y will be. So let's say if x is 3, let's figure out what y will be. So I'm going to use my rule, 2 times my x, which is going to be 3. So that would be 2 times 3 is 6. So when x is 3, y is 6. I'm going to make that an ordered pair right here. And so I'm going to start at the origin, go over 3 on the x-axis and up to 6 on the y-axis. Okay, I can see my line. It's increasing a little bit faster than my additive pattern. So I'm going to connect my dots, trying to make it as straight as possible, but all right, and there. Okay. So notice a couple of things. Oh, let's draw an arrow to our blue line. So when we graph a multiplicative pattern, okay, it tends to look a little bit like this. Now, there's two things we always need to that will help us recognize. So tomorrow we're going to be actually given a line and a pattern, and you're going to tell me, is it additive or multiplicative? So today you were given a rule, and by the rule we can decide whether it's additive or multiplicative, right? Because an additive pattern will be adding, and a multiplicative pattern will be multiplying. And then we were able to create not only a table, but we were able to create a line, or we were able to graph it on the coordinate plane. Well, tomorrow we're going to kind of do the opposite. I'm going to give you the lines or the points on the table, and then you're going to tell me, is this additive or multiplicative? So let's observe some things about these two lines, and maybe that will help us for tomorrow. One thing that you will always know about a multiplicative line is the line will always go through 0, 0. Why is that? Why would it be that every time the x is 0, the y is also going to be 0? Well, let's look at multiplication. Does it matter that this number is 2? If I multiply any number by 0, what's going to be my answer? Right, it's going to be 0, right? So every time I put in a 0 here, it doesn't matter if my other number is a 2 or an 8 or 10 or 180 or even 3 5/10. If I multiply any number by 0, I'm going to get 0. So my multiplicative line is always going to go through the 0, 0, or it will always go through the origin. And then an additive pattern is always going to hit at another point on the y-axis, because it doesn't matter what I add to 0. If I add anything to 0, I'm going to get a bigger number than 0, aren't I? And so an additive pattern is going to go anywhere else besides the origin. So it could go through the 1, it could go through the 8, and really that's where it hits the y-axis is going to tell you what you're adding by. Let's say my rule was y equals x plus 8. Well, if I said x is 0, that means I don't go anywhere to the right, then my y is going to be 8. And so then I would know that my pattern is plus 8 because of where it goes on the y, where it hits on the y-axis. And let's fill out this line right here. Both of these lines, or both of these types of equations, are called linear equations. What does that mean? Well, it means that when you graph these two different kinds of equations, what do you get? Well, you get lines, don't you? So that is why both of these types of equations are called linear equations.